Start.
So, good morning, friends. I have a very special episode with the cameraman, my sister Rima Jaiswal, and the topic is antimatter with dark gravity. Previous episode was graviton unified field theory. It is a extension of that episode. It is, and a small amount of recap is needed. We assumed space is made up of vibrating 2D sheets. These sheets which you are seeing is a flat 2D sheet, but in reality every flat 2D sheet is actually in some kind of vibration. So that 3D projected surface is created. It also represents the basic unit of energy also. So when you see a deep space, for example, each sheet is in some kind of vibration, and because of vibrations, contacts between sheets are formed. Sometime between here, then next time maybe here, next time here, and so on. So it is a random connection between the sheets, random interaction between the sheets. But in this local domain, each particle of this graviton particle, graviton sheet, is in some random interaction. Okay. But we assume that this inherent vibrations, we are not concerned with this inherent vibration of graviton sheets. We ignore these vibrations for our movement. Okay, so that each sheet is perfectly flat. It has internal vibrations, so that random interactions take place among sheets, but we ignore that these inherent vibrations, so the sheets are flat. Now light travels as superimposed vibrations on these inherent vibrating flat sheets. So light actually is a superposition. It travels as a superimposed vibration with the speed of light c. So that sheets further, sheet length decreases, so that instead of one we may have two sheets when light is passing. And suppose one photon is moving in this direction, another photon moves in this direction. Okay, and collision occurs between these two vibrations. Then vibrations close. On collision, vibrations are not able to move, for example, because of collision. So vibrations close. Before collision, positive vibration after some time change into negative. Negative vibration after some time change into positive. Okay, cameraman? But that is light travels as vibrations. Positive, negative. But by the time when it travels, situation will change. Okay, positive become negative and negative become positive and so on. So, but when vibrations collide, when a similar vibration collide, then because of hindrance from the upcoming photon and vice versa, vibrations closes to form what? Positive vibrations closes for positive charge, then negative, then positive, then negative. Okay, cameraman. See here यार.
हाँ हम यही देख रहे हैं
ना cameraman. तो positive, negative. These are basic positive, negative. Okay. If all positive vibrations rearrange at center, then you will get positive nucleus surrounded by negative massless particles. Okay, cameraman. But symmetry arguments say that since seat is perfectly flat, although it has inherent vibrations, but inherent vibrations actually we are ignoring that inherent vibrations, or we are saying that inherent vibrations create symmetrical seats. Both seats are symmetrical. Don't worry. Both seats are, that is, inherent vibrations are symmetrical, so that we can ignore inherent vibrations, and so symmetry argument prevails. By the mechanism, this is matter is forming. Okay, an atom or matter is forming, but symmetry arguments say that antimatter may also form by chance, so that negative vibrations come closer, okay, and positive vibrations form the positron field, not electron field. Okay, this is matter, this is antimatter, this is antimatter. Okay,
बहुत सही.
Okay, cameraman.
हाँ एकदम perfect.
Rima. But in nature, in surrounding nature, this prevails. This prevails, and it is rare. That means the seats which we are considering a flat one, inherent vibrations are there, but these inherent vibrations we are considering were symmetrical, so that we can ignore that inherent vibrations. Okay, but that means we are saying that seats are in practical sense, ignoring inherent vibrations, are flat, so that matter antimatter will be created in equal amount. But since nature is completely made of matter, not antimatter, that means seats are not flat. Seats have some unsymmetry, some That is, seeds are unsymmetric in nature. It may have some curvature, inherent curvature due to inherent vibrations. Okay, it may have some curvature, these seeds. And now light moves as superimposed vibrations on these inherently curved graviton seeds. Okay, that's why we have more matter compared to antimatter. We are not going in instantaneous statistical argument, but for any statistical argument to prevail in each part of the universe, actually mechanism should be that matter should prevail compared to antimatter. That is, seeds are inherently unsymmetrical. So what we are saying is that space is filled with graviton seeds, and these graviton seeds have inherent vibrations, and these inherent vibrations means not symmetrical vibrations, but so that we can ignore and flat our seed. No, these inherent vibrations create unsymmetrical graviton seeds. Unsymmetrical graviton seeds. So that when light superimposes on this, matter prevails over this. Okay. How this is related to dark gravity? We are saying that each graviton particle, or even first take, it is symmetric. Suppose seed is symmetric. It has inherent vibrations. Okay. And vibrations are symmetric, so that seed can be considered flat, and in its vicinity we have such seeds. Okay, they are also vibrating. Okay, contacts are random. Contacts are sometime here, sometime here, sometime here, but totally in random way. We are not seeing any pattern in the contact. For example, 1 is contacted, then 3 is contacted, then 2 is contacted, then 1. But it is in random. But okay, it is in random. We are unable to find any pattern. So that we can assume these inherent vibrations are very symmetrical, so that for our purpose, for propagation of light as a superimposition on this vibrating graviton seeds, we assume that seeds are flat. But seeds, if we assume that seeds are flat, then matter and antimatter both should form in equal amount. In equal amount. But since matter prevails compared to antimatter, that means although we are seeing a pattern in a local level, for example, if you have a double slit experiment, okay, you have double slit like that, and you send only finite amount of electrons, only finite amount of electron. Then on screen, you will not see any pattern. You will not see any pattern. Limited number of electrons means no pattern.
No pattern.
That is, on screen electrons are in random dispersion. Okay. But when you have enough electrons, unlimited large number of electrons, then you will see a
pattern,
interference pattern. Okay, cameraman? Similarly, when you visualize graviton seeds on local level, you will see that these are random. But if you visualize whole space, whole graviton space on a very universal level, so this seed is in vibration, all our seeds are vibration, but these seeds not only interact in a random way with this seed or this seed, but you are taking further connections also, long range connections also. Okay, that means long range connections on local level in the vicinity. You will see randomness.
Yes.
But when you see interactions between the seeds on a large basis, this seed, then this seed, and then this seed, then this on a large basis, okay?
ठीक.
Then you may have some kind of long range pattern. Long range pattern. Although this pattern is not totally fixed. This seed may participate with next time with this seed, okay? Then it may participate with this seed, then it may participate with this seed. But overall, in long range, considering long range interactions of each seed, then you may have some pattern, okay? Which by local investigation around the seed, you will say it is random. There is no pattern. But in long range, you may have some pattern. That is, universe may have in the long range some defined, some degree of informed choice. Some degree of informed interaction. Okay? Degree of informed interaction in different parts of universe may be different. For example, in this part of universe, degree of informedness may be different, may have different pattern. In this part of universe, degree of informed may be of different pattern. Okay? But on local level, when you consider interaction, they are random. But on a large scale, degree of information may be different. Okay? What it means? It means is that gravitons sit in different parts of universe, whether this part or this part, considering only local randomness. So seeds are not flat, but seeds may have some inherent vibrations, may have some inherent unsymmetry, not flat, inherent unsymmetry on local level. These seeds are in random orientation, okay? But due to long range interactions, seeds are not flat, but they have some unsymmetry, okay? They have some, cameraman,
हमें देख रहे हैं भाई सिमेट्री वाला.
they have some inherent unsymmetry. Although contacts are random, but they are not flat for the propagation of light. Okay? They may have some unsymmetry due to long range interaction, which I am showing. Na? But degree of pattern of this long range interaction may be different in different part of universe. So if there was no pattern, then at every local level, seeds should be flat. Flat. But long range interaction, because of long range interactions at very large distances, very different parts of universe, local level seeds may be assumed somewhat unsymmetric. Okay? Somewhat unsymmetric due to long range pattern. Since nature of long range pattern in this part of universe is different, the curvature here, inherent curvature is different from inherent curvature here. Okay? Different. Okay? Although at local level, like flat seed, contacts are random. Okay? But due to long range interaction, seeds themselves are not flat. They are curved at local level. Okay? And they are curved, but contacts are random. But inherently seeds have curved nature due to long range interaction. but long range interaction in different parts of universe are different. Okay, that means in different parts of universe, suppose we have some inherent curvature in different parts of universe, and in other part we have some more curvature. Okay, and on both these sheets light travels as superimposed disturbance. Okay, superimposed disturbance. Okay, cameraman.
ठीक है.
So that matter wins. Here also, but degree of curvature is more. So here also matter wins. Okay, cameraman. But winning here is less because degree of curvature inherent is less. Long range interactions have different arrangement, so that inherent curvature is graviton sheets is less, and light when travels as superimposed wave, then matter predominates but less predominance. Okay, here matter absolute winning. Okay, rest, because of this unsymmetry, statistically matter wins both on equal amount. Statistically matter antimatter destroy itself, but less quantity initially, more quantity initially, but in long statistical analysis these two will give almost equal amount of matter, in many parts of universe. Okay, but there may be occasions, there may be parts of universe where symmetry or curvature may be just opposite or may be flat, so that appreciable amount of antimatter may be there. Okay, but and also since these graviton sheets have different inherent curvatures, okay, and I have shown previously that gravity is nothing but, suppose it has mass, so light is locked in a circular way, so gravitational field is nothing but closer to mass, more number of sheets, and then sheets less. Okay, here also mass in different part of universe, closer to mass, more number of sheets, but sheets decreases. Okay, but these sheets are not actually, they have inherent vibrations and also have some long-term patterns, so that they have some initial curvatures. Okay, so here mass surrounded by more curved number of sheets. Okay, and here same mass surrounded by less curved, although number is more compared to as this, both will follow 1 by r square law, but since sheets have initially more curved nature, due to long range interactions, so in this part gravitational force between two masses format will be same. Suppose masses m1 and m2 are same, distance is same, but this part may have different gravitational constant and this part may have different gravitational constant between same masses at same distance. Okay, Okay. So gravitational constant may change from in different parts of universe. In different parts of universe, but antimatter and dark gravity are related. What we are proposing is that degree of antimatter. What we are major conclusion is that, cameraman, degree of antimatter is actually a function of dark gravity. Okay. Dark gravity, so that inherent curvatures of gravitons because of long range pattern in space, gravitational constant may have some different value and may have different degree of antimatter compared to matter.
Thank you.
Thank you, Rima. Thanks a lot. And thanks a lot, Rima.
Thank you very much.
So that is the way. Somebody is watching. Krishna Kumar Jaiswal sir is watching. Thank you, sir. And Mario M. Abe sir is watching. Thank you. Thank you. So this is the explanation I want to give. So Dirac equation, great Dirac equation, which is highly gives matter and antimatter in equal amount, because it is it's believe in symmetry, but nature at local level, at quantum level, may have some asymmetry inbuilt, and these asymmetries are actually is a result of some long range patterns at the universal level. These long range patterns may have different orientation, shapes or informations, you can say, so that at the universal level, universe may have some degree of overall informational choices, and these are reflected in unsymmetric at the quantum level, and these unsymmetric natures is the prime cause that matter wins, antimatter lose. Rest is any such extra matter against antimatter. Next, statistical collisions will give further rest to the matter. But there may be parts of universe where just reverse may happen, and that parts of universe are very far away, and degree of antimatter and matter may be different, but all this is due to long range interaction between graviton sheets. At local level, local interaction level, you will see no pattern. A sheet surrounded by some number of sheets, and you are seeing the contacts, they are random. For example, theoretical basis. For example, sending some electrons from double slit, you will see no pattern, you will see a randomness. But large amount of electrons will show you interference pattern. Similarly, when you visualize interaction not between adjacent sheet but on a larger scale at universal level, then you may have some type of pattern or non-randomness also. The degree of non-randomness may vary in different parts of universe, so that at local level, although seeds may behave as they are in random contact, but inherently these seeds cannot be considered flat. Because of this long range degree of pattern and non-randomness or informed choice, these graviton vibrating seeds may have some inherent unsymmetry, and degree of unsymmetry at different parts of universe may be different, and because of that 1 by r square law will hold. But due to difference in inherent curvature of these seeds, value of gravitational constants may have some differences in different parts of universe. What I mean to say is that parts which are very far away, when you are seeing one galaxy to two galaxy or adjacent galaxies, you will see same gravitational constant, may see. But at very complex galaxies and where antimatter matter distribution may be different, then you may see different amount of gravitational force. You may conclude that since gravitational force are more in these rotating stars in these distinct galaxies, with the speed they are moving, that means gravitational force is more, that is mass is more. So but where is the mass? That means they may have some dark matter. But instead of this, we may say that gravitational constant is different in that part of universe because of some more asymmetric nature of inherent graviton seeds. And not only that, value of gravitational constant are different, they may have mass, same mass, 1 by r square law still holds, but gravitational constant may be different due to some inherent more unsymmetry in the graviton seeds. And the best way it can be represented in macroscopic way is that degree of antimatter may be and to matter ratio may be different than our part of universe. So it is just a theory. So that means to get a better theory, so we have to adjust the existing Dirac equation, which is purely symmetric. We have to adjust the Dirac equation, famous Dirac equations, to account for unsymmetry also. To account for different degrees of unsymmetry which any system at any part of universe may show, so that matter and antimatter are not produced in equal amount, but it may be adjusted. So thank you. On Facebook I have seen some very eminent physicist comment is that dark matter may not actually exist, but dark gravity or extra gravity may still exist, and that can be created by the same amount of matter but different value of g, according to this theory. So equivalently you can say that extra gravity is flowing from these unseen long range patterns, and these unseen long range patterns may be called gravity flowing from extra gravity flowing from some parallel dimension. In my interpretation, in our interpretation, dark matter may not have any existence, and that's why we will find, we may never find any dark matter. If we found so in very small amount, it may not explain the amount of dark matter responsible for this extra gravity in the universe. That means extra gravity is due to different value of gravitational constant and gravity, and due to long range different informational patterns in different parts of universe. Because universe is a balance of randomness and random. Degree of randomness overall is increasing at present in universe, but howsoever degree of randomness increases, entropy increases, maximum entropy will be reached. But in this maximum entropy stage also, at the universe level, universe may still have some degree of pattern left, and when process reverses, we may visualize arrow of time shifts from more entropy to a lesser entropy, and then more and more universe will be well informed compared to its previous stage, because entropy will decrease. These two processes, that is from Big Bang to expanding universe, increasing entropy, and then from maximum entropy, that is maximum expansion to towards before Big Bang conditions, it is a cyclic process. As Roger Penrose also proposes, great Nobel laureate, that Big Bang is not the beginning, but it is merely a junction, a reversible junction. But all this reversible cycle between increasing entropy and decreasing entropy stages of universe, are change in the arrow of time in a cyclic way, can only be possible if for this cyclic process universe have some amount of information, at least minimum amount of information or pattern, especially at highest expansion level or at its highest entropy level. Universe should have some degree of pattern, and that degree of pattern or randomness will decrease, and degree of pattern or information will increase as entropy of universe decreases, as arrow of time changes. But present randomness is increasing, degree of pattern or information is decreasing, and at maximum entropy stage randomness will be maximum, but universe will still have some degree of pattern or information that can revert the arrow of time, or so that from maximum entropy, lower degree of entropy, universe can move, and that is with that very small amount of information at maximum randomness, universe may capitalize and more informed degree of patterns may be formed, and randomness decreases further and further to the point of singularity, and then the process reverse again. And this is the way I am seeing the universe, we are seeing the universe, and that is the way we can explain antimatter and dark gravity both simultaneously without requiring extra elusive very high amount of dark matter. Jai Hind, Jai Bharat, Jai Vish. Thank you, Mario M. Abbas sir. Please share the video, please comment on the video, and please also look at previous episodes also. I am an outside university person, but I love the great universities of the world and great scientists of the world, and that is the way. If I am talking to you and if world is moving, then there should be some amount of unsymmetry, na? A symmetric world will stop. Universe should have some degree of inequality or unsymmetry at every level, and that unsymmetry actually runs the universe, and that philosophy actually runs every person or every planet or every thing on the earth. Otherwise, symmetry means full stop. Jai Hind, Jai Bharat, Jai Vish. Thank you, sir.